a student investigated one property of the alkanes here. This is the method used. Okay, great. And then we've got the diagram shows below the apparatus used. Yeah. The level of that alkane takes 6.4 seconds to reach line X. Predict the trend in times for the other two alkanes. Okay, give one reason for your answer. Okay, so we've got to predict what's going on here for the other ones. So let me just have a quick look at this. So we've got the alkane in here. So the alkane's in there. There's a tap there. They open the taps. They pour some in there. Open the tap and start a timer. As soon as they start a timer, this stuff's going to pour into there, and they keep going until the level, which is here, reaches here. Okay, so it's going to pour out through this pipe into this pot here, and they're going to stop it when it gets there. Okay, so they start off with the C5H12, then they're going to try C10H22, and then they're going to try C15H32. So this is the small one, the smallest, and this is the biggest. Okay, so what are we going to find? Well, as these things get bigger, so as these molecules get bigger, then the molecule's going to be harder to fit through that gap. So they're going to get the viscosity is going to increase. It's going to be less runny. We know that if I've got methane, which is really simple, methane's a gas, it would pour through there, it would race through that hole. Whereas obviously the longer they get, road tar, which is really long, would be C100, H202 or something. It's huge. It would take forever to get through that little gap. So what's going to happen? Well, as the molecules, as the alkane get bigger, the time taken would get longer. Okay, and why is that? That's because big alkanes are more viscous. And just in case, if you didn't know what viscosity means, because they become less runny.